Welcome again to my YouTube channel. My name is JALEEL. I teach chemistry at St. Joseph's Higher Secondary School, Baramulla. Today, I am here in front of you. This time, many students, they called me and they insist that some lectures on important topics like general organic chemistry be prepared so that in the coming exams they will be benefited. Keeping this thing in consideration, this time I will prepare a video. I'll teach in this video general organic chemistry, and today the first topic I will be delivering is inductive effect. Inductive effect. Dear students, you know a covalent bond is formed by mutual sharing of electrons between two combining atoms. Equally, one atom contributes one electron. For example, there is a covalent bond. This one, AB. AB, it is a molecule, and this line, it is a covalent bond. And this covalent bond contains two electrons. Got it? And you also know valence electrons of the participating atoms. They are responsible for formation of a covalent bond. This thing you know from bonding part. But one thing this time I will tell you. Suppose this atom B, if it is more electronegative than atom A, if atom B is more electronegative than atom A, then what will be the result? This shared pair of electron, it will shift in the direction of element B, because B is more electronegative. And what is the result of this difference in electronegativity? A positive and negative centers are created in the molecule. In other words, a molecule becomes polar. Separation of charge takes place because when this electron density shifts, so element B acquires partial negative charge and element A acquires partial positive charge. Here the molecule becomes polar. Polarity is induced. And what is the result of this polarization? Dipole moment is created. Also, many physical properties get affected. Ionic character, solubility, reactivity, melting point, boiling point, so many physical properties. Also, chemical properties get affected. And this polarization, this difference in electronegativity, same thing we will apply in case of organic compounds. In organic compounds, electron displacement takes place along carbon chain. In organic compounds, electron displacement takes place in organic chain, in carbon chain. For example, suppose we have a carbon chain, carbon, carbon, carbon. Suppose at the end of carbon chain there is an element X. For example, at element X is more electronegative than carbon. Then what will happen? Common sense, this covalent bond, it will shift more in the direction of X, because X is more electronegative, and this carbon, it will acquire partial positive charge, because sigma bond, sigma electron will get displaced towards more electronegative element, thus creating polarity, polarization. And additionally, this X, this shifting of sigma electrons, it takes place beyond first carbon. Carbon number second also feels attraction of X, and it also attains partial positive charge. But carbon number second attains less positive charge than carbon number first, which is directly attached to more electronegative element. And this displacement is also felt by third carbon, which also attains partial positive charge, but less than carbon number second. So what happens actually in this case is sigma electrons, sigma electron density, sigma bonds, they get displaced along the carbon chain. Along the carbon chain. Why? Because at the end of chain there is an element which is more electronegative. Got it? Good. So this shifting of electrons, this displacement of sigma electrons, I am not talking of pi electrons, I am talking of sigma electrons only. We call it inductive effect. We call it inductive effect. But one more thing I will tell you. These electrons, they get displaced, but still they remain in the valence shell of atom. Electrons do not leave the valence shell. Mind it. So this thing is called inductive effect. Now I will write the definition of inductive effect. Inductive effect is, it is the partial but permanent, partial but permanent displacement of sigma electrons along the carbon chain, along the carbon chain. Okay, this is the statement of inductive effect. Here I have written, it is partial effect. That is, sigma electrons do not leave the valence shell of atom. Partial. Number second, it is permanent. It is not temporary effect. It is a permanent effect. Then what effect it does? It leaves in the molecule. What changes? What properties it affects in the compound or in the organic compound? It affects many physical and chemical properties. Like I will tell you, inductive effect. Second point, inductive effect influences many physical and chemical properties. Many physical and chemical properties. Of a compound. For example, it creates polarity. It creates dipole moment. It affects melting point. It affects boiling point. It affects solubility. Okay? It affects reactivity. It affects acidity. It affects basicity. For example, here I will write dipole moment. Melting point. Boiling point. Solubility. Acidity. Basicity. Sometimes reactivity. So many properties get affected as a result of inductive effect, as a result of displacement of sigma electrons along the carbon chain. Get my point? Very good. So it's a partial effect but permanent. Now this inductive effect, we have to explain its two types. It has two types. There are two types of inductive effect, and we have to also discuss applications of inductive effect in organic compounds. That will be taken care of in the coming videos, in the coming lectures. But today I will tell you two types of inductive effect. Inductive effect is of two types. Inductive effect is of two types. First one is negative inductive effect. Negative inductive effect. It's also called minus I. Minus I effect, or simply negative inductive effect. What is negative inductive effect? It is displacement of sigma electrons, the sigma bonds, away from carbon chain, away from carbon chain, away from carbon. When it will be observed, when carbon is attached to an atom which is more electronegative, so minus I effect is exerted by electron attracting groups, or we call them electron withdrawing groups. Electron attracting, which attracts sigma electrons, which withdraw sigma bonds away from carbon chain. They happen to be more electronegative than carbon. What are those groups? What are the groups which show minus I effect? So some examples. This is called nitro group. Nitro group NO2. It shows minus I. CN. Cyano. It also shows minus I effect. Carboxylic acid group. It also shows minus I effect. Fluorine. chlorine, bromine, iodine, OH, NH2. These groups, if they are attached or any one of them to the carbon chain, at its end, they withdraw sigma electrons away from carbon chain and exert minus I effect. Like this. This is fluorine. It is more electronegative. It will exert minus I and will acquire partial negative charge. And this is carbon. It will attain partial positive charge. And second carbon, it will also attain slightly lesser positive charge than first carbon. And carbon number third, it will also attain partial positive charge. Beyond 3 carbons, inductive effect is not observed. It is observed up to 3 carbons, creating polarization, creating separation of charge in the compound. So make note of this. It is called minus I or negative inductive effect. And in the coming lectures, you will see lot of applications in organic chemistry. To understand organic chemistry, inductive effect plays a very important role. Okay. Then second, positive inductive effect. Or it's also called plus I effect. What is positive inductive effect? It is displacement or simply partial but permanent displacement. As I have already told you, it is partial but permanent. Displacement of sigma electrons or sigma electron density towards carbon chain. Towards carbon chain. Okay. And this type of effect is observed when carbon chain is attached to electron donating group, electron releasing group. So it is exerted by electron donating groups or electron releasing groups. They release sigma electrons towards carbon, towards a functional group. Right? Now what are those groups? What are those groups we show plus I? You have to remember those groups. These are the groups. These are the groups we show plus I effect. Number 1, this one. This group, it is called tertiary butyl. Okay. Then number 2, it is called isopropyl. Similarly, we have this. It is called ethyl. And this is called methyl. Correct. So now minus I and plus I called tertiary butyl. isopropyl, ethyl and methyl. If these groups are attached to carbon chain, they release electrons, sigma electrons towards the carbon chain. Okay? And increase the electron density in the carbon chain. And they show plus I. So thank you for watching today. In the coming lectures, I will teach you applications of inductive effect.